Today we're going to be going over the three discontinuity problems I left, right? This is our first one, a piecewise linear function. Notice that the issue is going to be at x equals 4, right? So, we know for this to be continuous, we want the limit to equal the point. So let's find what the point is, because that'll be easier, right? So f of 4, well, this is at the interval from 4 to 8. This is the interval from 0 up to 4, right? So we're going to plug it into the bottom. Well, last time I checked, 4 plus 3 was 7. All right? Which means we want the limit as x approaches 4 from the left to equal the limit as x approaches 4 from the right to equal 7. Because if these two equal each other, that means that one side of the two side of the limit exists, and we want that to equal 7. Right? Okay, well, let's start from the left, which is going to be limit x goes to 4 from the left of e to the kx, limit x goes to 4 from the right of x plus 3. Right? Well, we plugged that in for the function, so we know it's going to come out to 7. So we're going to plug in a number a little bit less than 4 into this, right? So we're going to have e to the little bit less than 4 times k equals 7. Okay. What can we do? Well, we're going to take the natural log, right? Natural log e for a little less than 4 to the k equals the natural log of 7. Well, natural log and e are inverses, so they're just going to cancel each other out and leave us with a little bit less than 4k equals ln of 7. K is going to equal approximately a fourth of the ln of 7. And that will make this function continuous at x equals 4. All right. Now, this next problem is straight from the textbook, right? And we're asked to see if this function is continuous at y equals 1, right? As a bonus, if it's not, let's classify the kind of discontinuity. Well, let's just plug in y equals 1 and see what happens. We get sine of pi divided by the tangent of pi, right? Unit circle. Pi is going to be over here, so we'll have 0 over, right? Tangent of pi, well, that's just going to be sine of pi over cosine pi, pi, which is 0 over negative 1, which is 0. So if we just plug it in right away, we get 0 over 0. So it's discontinuous. Now we gotta figure out what kind of discontinuity, right? So I see this trig and my mind says, can I simplify this? Because I essentially have sine of pi y cotangent, not cosine, cotangent of pi y. This is the same thing as sine pi y times cotangent is cosine over sine. Cosine of pi y divided by the sine of pi y. So, this will cancel out, and we're left with cosine of pi y, which we said was negative 1 at y equals 1. So if we do some algebra, we do get a value of the function. However, in its original state, it's discontinuous. I'll give you a second to think about what kind of discontinuity that is. Right? So it's a removable discontinuity because we removed something from the original. Awesome. Now for the last one, or the three practice problems. This is the last question. Let's get to it. Right? Where could it be discontinuous? Well, for that, bottom would equal 0, x would equal 3. So we want to check f of 3 and the limit x goes to 3 from the left and the right. Well, if we plug in 3, we get 7 over 0 plus 8. So that's a determinant, so it does not exist. Okay, what if we plug in something just a little bit more than 3? Well, then we get 7 over a really, really small number. So that kabooms up to infinity. You add 8, that's still an infinity, right? Then you have the limit as we plug in something a little bit less than 3. We get 7 divided by a really small number. So it becomes negative infinity. This should be a very obvious choice as to which kind it is. I'll give you a second. If you guessed an infinite discontinuity, you're correct. So yeah, the main problem the main kind of problem you'll encounter with this is classifying it based off algebra, because they'll give you like a nasty equation so you can't really graph it by hand. Or they ask you to make it continuous if it's a piecewise function. So yeah, overall, not too bad. I know you did good, so good job. With that being said, if this was helpful, consider leaving a like. If it wasn't so helpful, leave a comment as to how I could improve. And if I was really helpful, maybe even subscribe. As always, it's somewhere around here. I don't know where I put it. It's a fun part of, you get to see me look like a clown here, but it's somewhere in these two directions, or it's right over my face probably. So yeah, thank you for watching and have a good day.